Okay, so let's take another little quick break and let's just talk about like, all right, I went to this Rust presentation and it sounded super cool. I'm going to go home and I'm going to write Rust. All right, well, what do you do? So, oh, whoops, you don't click on the...
Open up your fast scripts.
Yeah, I haven't paid for it yet, but maybe I will. Okay, getting started. All right, what are you going to do? Well, first thing is you're going to press the right button. Okay, there we go. You're going to install the Rust compiler and friends. I know piping something in SH may not seem like the coolest thing, but you're going to be running arbitrary code anyway, so if you're really afraid, then you've got more problems. So anyways, you can curl that, pipe it into SH. It'll install the Rust compiler and friends, including cargo that we have mentioned. Maybe a couple of things, that's mostly it. Clippy, does Clippy by, no, Clippy's not by default. You have to install that.
It does come by default now.
It does?
Yeah, just did it.
Well, apparently I'm out of date. I'm not up to date with my Rust news. Okay.
Way back in the day when we didn't have Rust format included in our distribution.
Oh yeah, Rust format is by default. I didn't know that. Okay, and then, so like I mentioned, a project in Rust is called a crate. Why? I don't know. It's cute. And so to create a new one, use the cargo tool, and you say cargo new, right? This is very familiar, npm or whatever else. And then you go and you edit your file, main.rs, right? Oh yeah, rs is the extension for Rust files. And then you compile it and run, just cargo run. Pretty easy, right? Now, if you come from like JavaScript node land or whatever, this probably doesn't sound crazy, but if you're coming from like C and C++ land, I don't know, for me, this was like a breath of fresh air. Like, wow, it's so easy. So I think it's pretty cool. And then if you want to test your files, you write your tests, right? Tests are wonderful. Cargo test, run them all, great. We're gonna talk a little bit about ownership. I'm not gonna go over all of it, and I didn't quite finish, like I didn't make as many slides as I thought it was, but it was also kind of getting long, so. All right, so what is ownership? So ownership in Rust means these three rules. Every piece of data has a value, has a variable that is the data's owner. There's one owner for every piece of data has one owner. It's great. And there can only be one owner at a time, right? You can't have multiple people owning one piece of data. There's one person who owns one piece of data. And when that owner goes out of scope, when that variable or whatever it is goes out of scope, then that is when the data gets dropped. So this is in contrast to garbage collection, essentially, right? So in a garbage collection, you create a new object whenever you want, and it keeps track of who knows about it, who has references to it, and periodically it'll look at it, and it's not quite as simple, it's a lot more fancy, but essentially it's like, oh look, let me count up how many people own it. 1, 2, 3, all right, 3 people have a reference to it. Let me look, all right, 1 person has a reference to it. Look down. Oh, look, 0 people have a reference to this data. It is now out of scope, and then it gets cleaned up. That's how garbage collection works. In Rust, it knows there is an exact point in which the owner goes out of scope, and if the owner goes out of scope, all the data he owns is now out of scope, and it will get dropped. So that's cool. So we'll look at that really quick. So this x equals 15 thing is kind of silly. It was just I wanted to create a new scope. Technically, you can actually just have curly braces, but I just always feel it looks weird. So anyways, inside this if statement, we're going to create a new string. Rust, just as a side note, Rust treats strings differently than almost every other language. They look more complex. It's not because Rust is more complex. It's because strings are complex, and everyone else is lying to you. So anyways, at least that's what Rust tells you. You can believe it if you want. Right here what I'm doing is I'm saying I want an owned string. What this means, like strings, sorry. When I do this, it's like I'm going to put this on the heap. Technically this could grow, right, kind of like a vector. Maybe I should have just done a vector. It's going on the heap. It could change, but it is the owner is S. S is the owner of that data. Oh, I can highlight S, maybe. And we can use it just like normal. We can print it out, hello world, and right here. So at the end of this block, it goes out of scope. So normal rules apply, right? You can't use a variable before you create it. Pretty standard, pretty much every language does that. And then once it goes out of scope, that data is dropped, and you can't use it out here, right? So in general, right now, that kind of just looks like normal scoping rules, right? Like, I mean, that's how it works in C and Java, and not JavaScript always, but so in general, that sounds like scoping. The difference here is that in Java, this string or whatever, like strings might be different, I don't remember, but data right here that gets allocated would not necessarily go away right here, right? That's a whole, once again, that's garbage collection, right? You don't know when it's going to go away. In Rust, you do. Like there's code in the background that will get run right there, and it will deallocate that memory.
Not even in the background, in the foreground.
Sorry. Like implicitly, yeah, code that you did not write gets run and gets rid of that code. So that's cool.
It's static type, it's built type.
Yeah, well, the code is runner, yeah. But it's very fast because it doesn't have to like keep track of who owns it, right? Like it's like, all right, and right here at this line, right, line 42, we print something out. Line 43, deallocate the memory, right?
Call free.
Super cool. Yeah, call free, exactly. Cool. All right, so what does this stop us from doing? Well, it stops us from making terrible mistakes. So one concept, so we mentioned that every piece of data has one owner, but it doesn't have to be the same the entire time. You are allowed to move the owner. You can transfer ownership to something else. So if I go here and I say, all right, S1 is the owner of this string. He owns that text, hello. And he's like, all right, I'm done with it. I'm now going to put it inside of a different variable. Now, right here, very pointless, but for demonstrative purposes, a lot of other cases, it would be meaningful. I've now moved ownership from S1 to S2. Now, S2 is the owner of the data. Now, whenever S2 goes out of scope, it'll get dropped, right? And when S1 goes out of scope, nothing happens because he doesn't own that data anymore. And once again, all of this analysis is happening at compile time, so you don't have to analyze anything at runtime, it just happens when it needs to. So right here, so right here, this last line is fine, right? S2 owns some data. He can use it, he can print it out. This line will cause an error because S1 does not own the data. He can't use it anymore. He's essentially you can think about it, S1 went out of scope. Doesn't look like went out of scope from like what we think about scope from C and Java and JavaScript, whatever, but he's essentially out of scope. So if you try this is the error you will get. And let's just point out, like, for one, I just think this looks pretty, right? Like, look at this nice little code. It has the line numbers for you, and it's so helpful. I think the Rust compiler is great.
It's in color too.
It is in color when it's not on my screen. I can like pull up some code, we can run it. And look at this, right? Let me explain to you why you can't do that. So the move occurs right here because it does not implement the copy trick. We'll talk about that in a second. It got moved right here. I'm going to underline right here. This is where it moved. And right here, you tried to borrow it. We'll talk about that in a second too. Right, like that's just amazingly helpful. So like it just told you exactly what I told you in less words and probably you understood it better, right? And it told you here, here, and here. This is where it went wrong, right? And this happens all the time in Rust. It just like tells you exactly what you did wrong, why it's wrong, and a lot of times how to improve it. This one, it's not really telling you how to improve it because there's something kind of fundamentally wrong about what you're doing. So any type with a dynamic size, so think strings and vectors, hash maps, whatever, anything that can grow, right? That has to live on the heap, and that has to get allocated. It'll get deallocated when you're done with it, and someone has to own it. So cool. The Rust compiler mentioned this copy thing. What does that mean? Well, anything that implements the trait copy, don't have to worry too much about what that, like how that looks, but if it is a copy piece of data, then you're allowed to just copy the bits around. So think like an integer, right? Like I've got 4 bytes, they represent an integer, and I'm going to use it somewhere else. I can just give you those 4 bytes. It's not that expensive. I'm just going to copy it onto the stack, and then you have it. You don't have to go all the way to the heap and do an indirect memory reference, right? This is how primitives work in most languages, right? Like in Java or C. Same thing. Pass around an int, he's just going to copy the bits. And the great thing is that you don't have to go and like worry about who owns an integer because you don't really care who owns an integer. It's just bits. You do care who owns memory in a vector. So that's the difference there. And it's kind of the point here is that if you did the same thing, but you did it with an int, you said like x equals 5, y equals x, you were still allowed to use x because you didn't move the data. You copied the data, right? So you both have your own copy and you can both use it, it's fine. All right, so that's the difference there. If it's not copy, then you can't do that. That you're probably getting, if you're new to this, that might sound a little confusing. I would have been confused. It'll make more sense as you get along. Okay, so borrowing. We've mentioned the word borrow a couple of times. What does that mean? Okay, well, it would be very obnoxious. So there is a world you could live in where there is no such thing as borrowing, and every single time you wanted to do anything, you had to transfer ownership. And what you might do, I should have written a function that looked like this. They have it in the Rust book if you start reading the Rust book. You could live in a world like this. You're like, all right, I have a string. I want to maybe I'm going to count the number of digits in my string, right? Something stupid, right? So I'm going to hand it to a function, and he's going to count the number of digits in the string. You could live in a world where that requires moving the string into that function. Now he owns the string, he counts the numbers, and then he has to return to me the string and the number again for me to get it back. Because otherwise the string is going to go away because I moved it, right? He can move it back to me, and that's fine. You can do that. And I actually have written functions sometimes that maybe kind of make sense to do that-ish. So you could move it into the function, he can do something, and then give it back along with something else. You could live in a world like that. But it's very obnoxious. It does not sound very fun. So instead, what we do is we let people borrow our data. So we're not transferring ownership, we're not moving anything. We still own the data, but I'm going to let you borrow the data. Yeah, I'll tell you where it lives, and you can go see him, and you can go look at him. But in this situation, you can't change it because you have an immutable borrow. So that's what's happening in this screen right here. So I have this description function. It looks at how long the string is, and it determines whether it thinks your string is long or short. And then he's going to create a new string and give it back to you. So now you have two strings. You have the original one, and you have a description. And now you can use them both, right? So I have a string. I passed in a reference to that string. That's what the ampersand means. It means, hey, I'm going to tell you where this guy lives. And it's a pointer. Let's be honest. It is a pointer. That's what it is. I'm going to give you a pointer to that string. And now you can use it. You can go and look at it. You can call methods on it as long as you don't change it. Because this is an immutable, right? Cannot change reference to the data. The length function does not change the underlying data, so it's fine. You can look at that, and great. So now we can use this s here, right? In our old example, it stopped us from doing that, right? Because we moved it. In this case, we did not move it. We just let it borrow. So now we can use s and description. Great. Okay, so that's just how we write functions. 90% of functions take references, I would probably say, right? Like sometimes you'll take ownership, but more often than not, you're going to take a reference. Because most of the time, you don't really need to own the data. You just kind of want to look at it and do something with it. So great. So the rules with borrowing and references are, you either can give away as many immutable references as you want, right? As many people you want can look at it without changing it, or you can give exactly one person a mutable reference, meaning that they are allowed to change it. Now, this is important because this is basically so data races is what reference, right? Race conditions, there are some that still exist, right? So data races don't exist because you never have more than one person changing the data. To change the data, you either have to be the owner of the data, in which case it's fine because you own it, and there's only one owner, or you have to be the only person who has a mutable reference, and then eventually that mutable reference will come back, and then you will be the owner again, and you'll have it again, and everything's fine, because you knew he was changing it. You gave him a mutable reference. If you try to give one person a mutable reference and one person an immutable reference, that's when you start to have problems, right? That's when you have the read after write and write after read things, right? One person looks at X and then adds 1, the other person looks at S later and then adds 1 again, and then you get a 2. Anyways, right? All sorts of problems. Yeah, and I wish I had more to tell you about that. And if you want to, I can pull up an editor and we can go through some code. That is all the slides I had about borrowing.